everyone, welcome to Swayam course on image processing using Python. My name is Dr. Dipti Verma, Associate Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. In this tutorial, we will explore the world of image processing and how it can be accomplished using the Python programming language. While we will cover multiple libraries and frameworks, one that we will frequently utilize is the OpenCV library. So, let us begin with the discussion for today's topic on introduction to digital images and image processing using Python. So, what is image processing? Image processing is a powerful technique that enables us to manipulate digital images, enhancing them or extracting valuable information. By applying various algorithms and methods, we can achieve desired results and uncover insight from images. Python is an ideal language for image processing due to its simplicity and the availability of numerous libraries and frameworks. Among these, OpenCV, that is open source computer vision library, is one of the most popular choices. OpenCV offers a rich set of functions and tools for image and video analysis, manipulation and processing. Throughout this tutorial, we will delve into different aspects of image processing using Python and OpenCV. We will explore techniques such as image filtering, edge detection, image transformations, object detection and more. Moreover, we will discuss various practical applications where image processing proves invaluable. By the end of this tutorial, you will have a solid understanding of how to perform image processing tasks using Python and OpenCV. This knowledge will empower you to apply these techniques effectively in your own projects. Let's embark on this exciting journey into the world of image processing. What is image processing? Understanding the concept of image processing is essential before delving into its implementation. Image processing, also known as digital image processing, plays a crucial role in the field of computer vision. While these terms may sound similar, it's important to comprehend their relationship. In image processing, algorithms are applied to digital images, transforming them to enhance their quality or extract specific information. The output of image processing remains an image which can undergo various modifications. On the other hand, computer vision algorithms analyze images to derive features or obtain information about the content of the image. In summary, image processing focuses on manipulating and improving images, while computer vision aims to extract meaningful insights or features from those images. Both domains have their unique applications and are interconnected in the broader field of visual analysis. Now that we have a clear understanding of image processing and its relationship with computer vision, we can proceed to explore its applications and benefits. Why do we need it? Raw data that we collect or generate often requires pre-processing before it can be effectively used in applications. These pre-processing involves analyzing the data and performing necessary transformations to make it suitable for further use. For example, let us consider the scenario of building a cat classifier. To train the classifier, we would need a data set consisting of hundreds of cat images. However, the images collected may not have the same size or dimensions. To address this issue, we need to pre-process the images by resizing them to a standard size before feeding them into the model for training. This example highlights the importance of image processing in computer vision applications. Image processing allows us to address various challenges associated with raw image data such as standardizing sizes, adjusting brightness or contrast, removing noise and much more. By applying appropriate image processing techniques, we can improve the quality of the data and extract meaningful features, making it easier for computer vision models to analyze and interpret the images accurately. Image processing plays a vital role in preparing data for computer vision tasks and is a fundamental step in developing robust and accurate vision based applications. Prerequisites. Before we proceed, let us discuss the prerequisites for following this tutorial effectively. It is recommended to have some basic programming knowledge in any language as a foundation. Additionally, familiarity with the concept of machine learning and its fundamentals is beneficial, as we will be utilizing machine learning algorithms for image processing in this tutorial. However, prior exposure to OpenCV is not required, although it can be helpful. One crucial prerequisite for understanding this tutorial is knowing how an image is represented in memory. An image is essentially a collection of pixels which are stored as a matrix of pixel values. In this case of grayscale images, the pixel values range from 0 to 255, representing the intensity of each pixel. For example, a grayscale image with dimensions 20 cross 20 would be represented by a 20 cross 20 matrix comprising a total of 400 pixel values. When dealing with colored images, it is important to understand that they have three channels: red, green and blue, known as RGB. Consequently, a single image will have three corresponding matrices. These matrices capture the pixel values for each color channel, forming the complete representation of the colored image. Having a grasp of these concepts will enable you to learn along smoothly as we explore various image processing techniques in Python. Now that we have covered the prerequisites, let us dive into the exciting world of image processing with Python. Installation. So, first we will start with the installation process. Note, since we are going to use OpenCV via Python, it is an implicit requirement that you already have Python version 3 already installed on your workstation. For Windows, we use pip install OpenCV Python. For macOS, it is brew install OpenCV3 with contrib with Python 3, and for Linux, it is sudo apt get installed libopencv dev python opencv. To check if your installation was successful or not, run the following command in either a Python shell or your command prompt, that is import cv2. How to implement it? Image processing using Python is a fun way to understand how pictures can be represented via math and code. I hope that this short article can give you an idea of how your machines understand image data. Let us get started. First, import the required Python libraries like import numpy as np, import matplotlib pyplot as plt form, skimage import image as unit. From skimage.io import imshow imread. For skimage.color import RGB to HSV. From skimage.color import RGB to gray. Great. Now that we have imported the required libraries, we can begin with the basics. An image can be thought of as a matrix where every pixel's color is represented by a number on a scale. see, here is an example like array, that is np.array, the value is 2550. This value is predefined, we can change it. So, I am show array 1 C map is equal to gray, and this is the output which we will get. The above output is a visual representation of the matrix we just created. Note that we are not limited to a simple 2 cross 2 matrix. Below we have giving an example of a 3 cross 3 matrix. So, we have that is array 2 np dot array 255, 0, 255. So, this is an example of 3 cross 3 matrix, and the desired output will be shown next. This is the output of 3 cross 3 matrix. Although our examples were picking colors on the extreme end of the spectrum, we can also access any of the colors in between. Remember that you do not have to manually encode each number. The below image was constructed with the use of the arrange function of NumPy and created another image by getting the transpose of the first one. So, here are the statements of Python, that is array spectrum is equal to mpy dot array np arrange 0 to 55, 17. So, these are the syntax of your Python language, and this is the output generated, that is arrange generation and transpose generation. For simplicity, we have been using grayscale, but please remember that the machine actually understands colors as different mixtures of red, green and blue. As such, we can represent images as a 3-dimensional matrix, each pixel being represented as a Python list that specifies their color mix. So, this is the example, that is array of colors np array 25500, and then we have I am show array colors. So, the output will be the red, green and blue color segregated. Let us try manipulating an actual image. Below is an image of a lovable doggo. Doggo is equal to I am read. Doggo is in PNG format, the image is in PNG format. I am show doggo. So, this is the output which we will get, that is the image submitted, which we have to further translate into various applications of Python. Doggo shape 390, 385, 3, this you can give any range in this. Size of doggo image. Checking for the size of the image, we see that it is a 390 cross 385 cross 3 matrix. Remember that using Python, we can slice this matrix and represent each section at its own image box. For this, we have these codes. So, this we have split doggo into first split, second split and third split. Remember that although you can do this for all images, each image will have different dimensions. Essentially, what I need was find the dimensions that would split my image into 3 equal parts. Depending on the dimensions of your image, you will have to specify different figures. Below are the specifications for the dog's face. I am show doggo, that is 95 is to 250, 130 is to 275. So, this is the face of doggo which I gave the dimension value. So, from the whole image the face of doggo is extracted. Now, let us have some fun. Remember that previously we started that an image can be represented by a 3-dimensional matrix with each list specifying the color mix. It is matrix doggo. Each row represents the specific pixel color. We can actually call each of the numbers individually. The numbers can then give us a representation of the image red, green and blue components. For example, we have here figure AX is equal to PLT dot subplots 1, 3, figure size 12, 4. Next is your I am show, and this is the output we get for RGB images, in which the images is represented with the color according to the codes provided of Python. Like we can see this in this image, red, green and blue images. Additionally, we can convert the image from RGB, red, green, blue to HSV, that is hue saturation value. This will give us aforementioned figures for hue, saturations and values. So, the code for this Togo HSV is equal to RGB to HSV. So, and then we will write I am show to see the hue value, and next the same code for saturation and value. And this is the image which we will get for hue saturation values. This will be the output. Lastly, we can also convert the image matrix to grayscale by we transform the image to a simple 2 cross 2 matrix. This allows us to easily filter our image based on each pixel's relation to a specified value. So, this is the syntax for conversion of RGB to gray. So, this is the values according to the mean values objects, and here we have the output of the binary Dogo converted into grayscale, and with the help of this output we can actually generate the edges and contrast values of the images. That should give you a basic understanding of how to load and manipulate images using Python. To get a better understanding of image processing, it would be best if you could play around with the codes. I would also encourage you to start by processing images of topics you actually like. In my case, nature has always been a great source of inspiration. The Introduction to Digital Images and Image Processing using Python course has provided a concise yet comprehensive understanding of the core concepts and techniques in the realm of digital image processing. Through practical examples and Python coding, learners have gained the ability to manipulate images, enhance their quality, apply various filtering methods and segment objects within images. What are the outcomes? First, fundamental understanding. Learners have gained a strong fundamental understanding of digital images, including image representation, color channels and image formats. They now comprehend the basics of how images are processed and stored in a digital environment. Second, image manipulation skills. Through hands-on exercises and coding examples, learners have acquired practical skills in loading, displaying and manipulating images using Python. They can now resize, crop, rotate, flip and perform various other transformations on images with ease. Image enhancement techniques. Learners are now proficient in applying image enhancement techniques to improve the visual quality of images. They can use methods such as histogram, equalization, contrast, stretching and adaptive filtering to enhance important image features. Filtering and feature extraction. The course has equipped learners with the ability to apply different filtering methods, including convolution mask, to perform tasks like blurring, sharpening and edge detection. These skills are crucial in noise reduction and extracting meaningful features from images. Image segmentation. Fifth, that is, the learners have gained insights into image segmentation techniques such as thresholding and region based segmentation, allowing them to partition images into distinct regions. This skill is valuable in object detection and image analysis. Sixth is the image transformations. Understanding various image transformations such as Fourier transform and Hawk transform enables learners to analyze images in the frequency domain and perform advanced image processing tasks. Advanced topics and applications. The course has exposed learners to advanced topics including image registration, image stitching and deep learning based image processing. This knowledge opens up opportunities for tackling complex real world problems in computer vision and medical imaging. Confidence in Python. By implementing image processing algorithms using Python libraries like OpenCV and PIL, learners have gained confidence in their programming skills. They can now apply their knowledge to solve other computational challenges. Overall, the outcomes of this course empowers learners to navigate the world of digital images and image processing with practical skills and theoretical understanding. Whether pursuing careers in computer vision, graphics or related fields, or simply using image processing techniques for personal projects, the knowledge gained from this course forms a solid foundation for future endeavors. Before we conclude this lecture, let me take a moment to introduce the experts who will be guiding you through further lectures in this course. Our team of seasoned professionals brings a wealth of knowledge and experience in the field of digital images and image processing using Python. We have Mrs. Bharti Patel, Assistant Professor and also the course coordinator from Chhattisgarh Swami Vivekanand Technical University, Bhilai. We have Dr. Atul Dwivedi, Assistant Professor from Bundelkhand Institute of Engineering and Technology, Jhansi. Dr. Archana Sahu, Associate Professor from Rungta College of Engineering and Technology, Bhilai. Dr. Supriya Gupta, Assistant Professor from Cummings Engineering College of Women, Nagpur. If you have any more questions or need further help in the future, don't hesitate to reach out. Happy learning and best of luck with your endeavors. Have a great day. Goodbye. Thank you.